Well, hi everyone. This is Scott King over at Zimperium, and thanks for joining our webinar on app shielding versus in-app protection. So we get a lot of questions about the differences on how we're building apps, how we are securing apps, what's going on in the market with operating systems, and really what the difference is between app shielding and in-app protection. So what I want to do is go a little bit into the operating system vulnerabilities and some of the research that our Z-Labs team has put together to show some trends. We'll talk about app shielding and what it is and what it protects. We'll talk the in-app protection, show you some examples of where apps that are on millions of devices, how they were breached, what happened. We'll talk about some of the differences, and then I'll give you a checklist at the end of the webinar to make sure that you're looking at all the different vulnerabilities and threat vectors in your app. If you would like the slides of the presentation, I will post those. We also have a detailed blog post on describing this entire process. But what I want to do is really give you an idea of what we're talking about. So we build mobile apps on a mobile operating system, and we are inherently dependent on the operating system for a lot of security features. So just like you would build a city block on the ground, if the ground moves, as in an earthquake, so does your app. So you are vulnerable to what the underlying security features, the underlying operating system. And if the operating system is vulnerable, your app therefore becomes vulnerable because it's operating above the operating system in user space. So that's really the kind of the theme that I'm going to talk about today is, how do you defend yourself against building on top of a ground that's moving? So the operating system that's always moving and it's always evolving. So what we looked at for the first half of 2019 was, what kind of CVEs get registered in the operating systems and how fast are they fixed? So in the first half of 2019, Apple patched 185 CVEs compared to 120 during the first 6 months of last year. And what's interesting is how many critical CVEs there are in the operating system. So a critical CVE is allowing a remote attacker to manipulate your device. So this isn't someone that is grabbing your device at a dinner party and unlocking it, and they know your PIN code, or they you hand it to them, or they show it in front of your face and it unlocks. This is someone actually remotely capable of manipulating your device, and then those gets fixed in the operating system. So at the same time, the apps you build are vulnerable as well because it's residing on top of this operating system. So in Android, same story. Google patched 255 CVEs compared to 492 during the same time frame last year. So this actually decreased from the different time periods, but yet the number of high and critical CVEs is still significant. So there were 50 critical CVEs repaired in Android over the first half, and 200 high. The difference here is a critical CVE is, again, it's the remote execution or the remote manipulation. High is local. So I can still manipulate your device, but I have to do it locally versus remotely. And so that's important because, we hear the stories about poorly coded apps. A lot of user data is leaking. There was a story out today. There's another dating app. It leaked all of the data from all of the users, 1.5 million users. You can go check it out on TechCrunch today. Zach Whitaker wrote that article, and it's pretty good. And so what we want to do is realize that the trend of these CVEs are increasing, okay? On the top here is iOS. And so if you can look at from the past couple of years, the number of critical and medium CVEs increases because Apple is pumping more and more functionality into the operating system, and it has unintended consequences in other areas. So it's those unintended consequences that are creating all these bugs that they have to fix. So that trend is increasing. Over Android, it's pretty stagnant. Still a significant number of unintended consequences, but it's not increasing at the rate of iOS. So if you're looking, if you guys are always arguing iOS is more secure than Android, we don't really see it that way. They both have the same number of vulnerabilities. They're both vulnerable. They both need app protection, and so you really need to make sure that one, you are covering your bases. So more than 70% of all of those critical CVEs, allowed an attacker to execute code. Google finds a lot of these. There was the FaceTime vulnerability earlier this year that actually forced Apple to remove the entire feature from iPhones. At Black Hat this year, Apple, the Google Zero guys did disclose and talked about the research on all the different zero days that they found in the latest iPhones. So definitely severe, and you need to make sure and cover your bases. So what do we do to cover our bases? Well, we do two things. We do app shielding and we do in-app protection. And you can see here there is a vault door. So the vault door is really your hardening, right? I want to lock all of my features. I want to lock down my APIs. I want to make sure and have local security. But what happens is, your app is still there, but it's kind of like hiding the safe behind a painting. You can disguise where your safe is, but it's still there, okay? So what we do is, hiding against hiding our app in the painting is just like the code obfuscation. So we make it more difficult for a human to read the binaries and the code. So we scramble it up and we think we're done. Okay, the app developer will understand and says, okay, I've done all the obfuscation. There's no way that anyone could reverse engineer my app. But even with the best practices, apps are vulnerable. Now you can see here on the left-hand side, this is a screenshot of the secure end-to-end messaging app, Telegram. And you can see here that in memory, whatever you type in the app, it's available in memory in plain text. So it's actually not encrypted. And so what happens is if you're able to compromise the device and actually read the memory and read from underneath the app, anything under the app is vulnerable. So this is just one example where that happened. So what you need to do is you need to have an alarm on your safe door. So if your vault door opens, if someone looks behind the painting or if they look beyond the code obfuscation, what you need is an alarm to make sure that someone is not intruding on your app. Because app hardening raises the bar, but you talk to any security person and they will tell you if they want to get in, they will. And they'll do whatever it takes, right? Because what they're going to do is they're just going to brute force their way into your app. And if you're not looking for intrusion, you'll never see it until you show up in the news where someone found your S3 database online, or the database was breached and then your user data is exposed, right? So a couple of examples. So BankBot malware has been out there for some years. The second generation of BankBot malware can actually capture the SMS authentication codes coming back to your users. So the first time we could defeat it, but then as more and more transactions are on mobile devices, the crime is going to follow, because that is where we're conducting our business. The next version of BankBot captured it. We've seen this. We actually looked at inside the BankBot malware, look which apps were actually being targeted, And we came up with a list of over 600 different apps that we found that were targeted by this malware. So very, very significant. And there are, marketing campaigns for BankBot to steal credentials from users so they can get funds. So another example that we like to talk about is Tesco Bank. So hackers stole £2.5 million overnight by reverse engineering the Tesco Bank mobile app. What happened after that, a couple of years, once they went through the legal process, the Financial Conduct Authority in the UK fined them $16.4 million for failing to exercise due skill. So basically what happened is um, the hackers reverse engineered the mobile app, found all the API keys, and drained all the money from 9,000 different accounts overnight. What's interesting is not all of those 9,000 accounts were mobile users. So some of those users didn't have the mobile app at all, because what happened is the mobile app disclosed all the vulnerabilities, and that's how they got in. They've never been caught, by the way. British Airways, intruders captured over 380,000 credit card numbers. If you read the GDPR fine, that is actually increased to 500,000. And basically what happened, this was a mage cart attack. So the criminals were able to get all of the transactions from a couple of months over all of these users, and credit card data, user data. They even captured the CVV credit card data, the authentication, 3 letters if you're using MasterCard and Visa, 4 letters if you're using American Express. So, that just shows you that the attack was not, read from a database online. It was actually stolen, in midair. So last year in the Verizon Mobile Security Index, Verizon interviewed and surveyed thousands of different security individuals, and what they asked them is, do you build your own app? So 70% of the entire security base in the survey build their own app. And the second question to those 70% of users, are you concerned about insecure coding? So more than half of them said that they were concerned about it. The mobile operating systems, again, they move out from underneath you so fast. The mobile apps require so much maintenance and updating on every version that they're concerned. They're concerned that their teams are incapable of keeping up with that. So you need to have, a real-time monitoring system to make sure that you're not exposing yourself and your app. Not exactly exposing yourself, right? But so 70% of fraud originated in a mobile browser or mobile app. So this is research from RSA, and what you can see is the mobile fraud and mobile app fraud is increasing over time. So as more and more of our transactions move to mobile, we need to make sure that we're covering the mobile browser. A lot of the critical CVEs that we talked about earlier are actually browser manipulation. So I can inject code into the browser via SMS message and compromise your device. So if you don't know who is inside your app, maybe Jack Nicholson is. So this just gives you an idea that, if I want to brute force my way in, I can brute force my way in. I may not do it cleanly. It may be an axe in a hotel, but I can get in. So what are we going to do about it? So here from left to right is how you secure your app. So on the far left, this is your app tampering, your app shielding, app hardening. So this is what most people do today. They're looking for, jailbroken and rooted devices. They're looking for, emulators. So is my app being run in an emulator? Is it being, in a bot, creating fraudulent transactions? And then I'm obfuscating the code. So there are varying solutions that do this. Most app developers, again, they're doing this, but what they're missing is what we call here route to compromise. So if I can compromise the operating system, whatever security features you have in your app are irrelevant. I can get underneath and I can manipulate, and actually I can perform actions that the user can't do because I'm underneath the user space. So what we look for and what we advise our app developers that are using our in-app protection is this list here. So are there risky configurations on the user's device? So this is unmanaged devices. So these are devices that your consumers are carrying, your users. Do they have side-loaded apps? Is it jailbroken? Do they have malicious processes running? Do they have encryption? So that was Android. No device pin, again, Android. And then whenever they're running around and whenever they're computing or doing their mobile banking or their peer-to-peer payments, what kind of networks are they using? So, you need to be looking for network attacks. Most of the attacks that we see in our threat database are over the network because that's how you're going to deliver the payload. That's how you're going to deliver the attack, or read credentials or read traffic is over the network. So you need to make sure that you can understand if the user is under a man-in-the-middle attack or if they're connected to a rogue access point. We actually do have instances where our users have identified rogue access points because they're spoofing the known networks, right? And then if you're able to get in and if you're able to deliver a payload, can you detect what is being changed in the operating system? So are there any device tampering threats, abnormal processes that lead to compromise, any file system tampering? So we give users or app developers the capabilities to understand what's going on in an unmanaged device. So if I can determine that these things are happening, I can look at some of the mitigation examples over on the right-hand side, and I can stop that user from accessing my backend systems, or I can, stop them from transferring so many funds at once because their device is compromised. So I'm trying to limit their funds from being drained into cyberspace, and then also I'm trying to reduce the overall fraud in my mobile channel, because if I'm a bank, I'm already pushing all of my users to mobile. I have marketing campaigns on TV and the internet to push to mobile and to get transactions to mobile. So I'm trying to use that channel and promote that channel. I need to monitor for fraud, just like I do in the web channel using a browser. And then the last section is malware. Can you even detect known malware on the device? On Android, since other apps can see other apps on Android, we actually have machine learning technology that can read unknown malware on Android. So that's an interesting spot where you need to look at, there are already all these different malware examples and malware campaigns going, trying to attack your users. Can you even spot that, right? So this goes way beyond emulator detection, looking at malware. So how do you get a in-app protection? So it's pretty simple. We have a cloud-based console with documentation and all of the SDK files to place inside of your app. Once you put the SDK inside your app, and you can just read the data that comes back to you. We do advise that users or app developers just read the data, come back to you, and then make decisions later in a month or two on what type of remediation that you want to put in and install. And then you just update your app, and the users don't know anything about it. And what happens is they just start sending you the real-time threat data as they use your app. So really, really simple. So who does this? So we've got lots of different customers. Most are in regulated industries, your utilities, your banks, your payment industries, peer-to-peer payments, things like that. And what one bank found was they were able to detect and look at all the different mobile transactions coming in, and they told us, easily 1.1 billions of fraud are being reduced in the mobile channel because they can now read threat data off of their consumer devices. So thousands of compromised devices, thousands of compromised networks that users were using to do real-time banking, lots and lots of rooted and jailbroken devices, and surprisingly, a lot of malicious apps. So they did spot a lot of malware after they started looking for it. And so what they see after they install this is basically all of the threat data coming into a central dashboard. There are different threat models. There are different threat types. We'll help you identify that here in the dashboard. You can look at monthly active users and daily active users on who is using your app. And this is using your app with the SDK in it. If someone doesn't update their app, obviously they're not going to be in this dashboard. But here's where you look at all the different threats and make decisions. This data can also be fed into fraud systems. So if you want to take the next step and feed that threat data into a fraud system, you could then model different remediation logic to make sure that someone's not draining your accounts. And then you can also look at the number of devices and the operating system version distribution. So here, this example, you got 2,000 Apple apps, and most of them are on 12.3.1. They need to be upgrading. And then you can see a lot of them are pretty old. So what happens is as the operating systems become obsolete, users need to update that and fix it with the patches. So you get a dashboard like this to take a look at that. So here's our checklist. So if you are developing a mobile app, you're probably doing the first 4. You are obfuscating your code. You're looking for debuggers, emulators. You are doing some rudimentary jailbreak and root detection. Most likely you downloaded some code off of the internet, you put it inside your app, and there are some root checks that are pretty simple. You may be doing some cryptography. If you are, you are. If not, you probably need to go look at a cryptography solution, do some white box cryptography. But what you are not doing, you're not looking for malware. You're not looking for bots. Clickjacking is someone roboting the actual user space of your app. So we've got some examples that were really interesting. Most of the bots and the clickjacking that we see are actually defrauding the advertising networks. So what they're doing is they're showing fake ads, or they're showing ads behind the app, and that code gets injected into fake apps into the Play Store. So they're defrauding the ad systems. Zero-day detection. So we know that you're not doing zero-day detection because we're one of the only ones that actually do this. So a zero-day detection would be, looking at someone that is manipulating the operating system without a known method. So if we see a threat in our backend database that says, file system change, well, we take a look at it and what did change? We're like, wow, this is an interesting, hack. This is an interesting method, and we remediate that for you because we can actually detect it. We detect it because the technology is actually running on your device in your app. And some of you may have some man-in-the-middle detection or prevention with some certificate pinning. That's a good method. But if you're not doing certificate pinning, you definitely want to do some man-in-the-middle detection. Configuration risk. This is what we talked about with our banking example. They had some unlocked devices, no PIN codes. They had malware on the device. So that configuration risk, they would limit those users from doing certain things, maybe peer-to-peer payments, things like that. Vulnerability detection. This is your operating system. Maybe you don't want people to make certain transactions if they're running on an older device. You can't force them to update their operating system. So you may want some data to make different decisions. We find overall in our data that people do not operate, they don't update their devices, and these are enterprise devices as well. So our latest data shows that that users take about 41 days to update their device. So so definitely a room for improvement because they tell you when to the update. So I don't know why people don't do that. And then the threat forensics. So Zimberium is the only one that actually gives you some threat forensics from inside of your app. So that was the dashboard that we showed you earlier. And you can take a look at what happens in the landscape, because what people always ask us is, what really happens in the landscape? How many attacks are there? Well, it's really easy to identify when you put in-app protection into your own app. You can have your own data set, and it becomes very, very valuable. So that is all I have for today. If you would like a free evaluation console for ZApp, you can definitely grab one of those, and we'll give you a production database with all the documentation. It's pretty self-explanatory. Just send me an email, king@zimperium.com. If you have any questions on the material or you would like the slides, please just email me and I'll send them right back to you and answer any questions about in-app protection. So thank you very much for joining me, and have a great secure day.